All right, this is Algebra 1 exam review for Chapter 4. So we started out Chapter 4 by looking at these percent problems, and we talked about writing them out as we read them and using some keywords for equals and for times, and then doing something special with the percent. And then once we've got the equations set up, they're super easy to solve. So for this one, we're going to write it as we read it. 76 is, we put equals, so 76 equals 4%. Now, 4%, we have to move the decimal. We don't put a 4. And you always move it 2 spots back to the left. So the big mistake people make is they write 4% as 0.4, which is actually 40%, which is obviously a big difference between 40% and 4%. So the decimal is always located right after it, and you got to go 2 spots to the left. So 76 is 4%, 0.04. Of means times what number, that's what we're looking for. So that's our x. And that's your equation. And then you're just going to go ahead and solve it. So you're going to divide by 0.04 on both sides. Okay, and x equals 1900. Now, 4% is a small amount of a number. So this should make sense. 76 is 4% of 1900. All right, going to the next one. It says what percent? I'm going to slide over here to the other side. What percent, that's x, of is times is your equals 33.6. Okay, so we're looking for the percent. This is going to give us a decimal after we divide here. And then because it's the percent spot, it's going to give us this decimal, and then we're going to move it 2 spots back to get the actual percent. So we're going to divide by 210. And when we do 33.6 divided by 210, we're going to get 0.16. And so since we're looking for the percent, we're going to move that decimal 2 spots, and the answer is 16%. All right, what number, that's x, is your equals? 20%. Decimal's always here at the end. You move it 2 spots to the left. That's 0.2. Of is times 205. This is an easy one. You just go ahead and you multiply. So 0.2 times 205 is 41. All right, then we start talking about these percent problems, kind of with some context. So the Smith family buys a new car. The total amount they paid was this. That includes the tax. And so we're going to go ahead and find the price before sales tax. And everybody always wants to take 8% of this and minus it off. But that's incorrect because the 8% wasn't from this final number. It was from the original cost. So the original cost, the amount that they paid, was 100%, whatever the cost was, plus 8%. So this number, 28250.75, is 108% of the original cost. Okay, it's 108%. So what we need to do here is move that decimal 2 spots. So boom, boom. So it's going to be, let's write this all the way out. 28250.75 is 1.08 of x. So all we have to do is divide by 1.08, and we'll get our original answer, the original cost, I should say, 26,158.10. All right, so if we now took 8% of this number and added it on, we will end up with what they ended up paying. Okay, we can't take 8% of this and minus it off. If you do that and then you take your final answer, take 8% of that and add it back on, you don't end up back here because 8% of this number is different than 8% of this. So we got to be careful whenever you've bought something and you've paid for it plus the tax, it's going to be a percent over 100. That's the key. Okay, a pair of jeans cost $45. They're on sale for 20% off. What percent do you pay, first of all? So you're taking 20% off. You are paying 80% of the original price. That's important because now when we go to write this, okay, we want to find what is, so let's actually write this out. What is 80% of 45? Because that's what we're paying. We're paying 80% of the 45. We're not paying 20%, they're taking 20% off. Now, you could find out what 20% is of 45 and then subtract it off, and you'll be left with the cost. That does actually work. But we can go straight to the answer by saying, okay, if 20% off, we're paying 80%. So what is 80% of 45? So what is x is equals 80% 0.8 of is times 45. And we're going to get $36. So for that one, if you use the 20% and you did it times that, you'd get $9. So if you're saying that you're going to pay $9 on something that was originally 45, that's a much bigger sale than 20%. Right? That's actually 80% off. And so we need to make sure if we did the 20% times it and you get the 9, we should recognize, okay, you're not going to pay $9. That's the amount that's coming off. 45 minus 9 then gets me to the 36. So you can correct yourself even if you kind of went about this the wrong way. All right, we start writing lines for horizontal and vertical lines. Horizontal lines going like this, vertical lines going like this. These hit the y-axis, and no matter where you go on them, the y value stays the same. So these are y equals something. Vertical lines hit the x-axis, and no matter where I go on that line, the x value stays the same. So it's x equals. So if they just give you these points and they want you to write a line, write the equation of a line, you can notice that every single point has the same either x or y value. That's a clue on how to write these. And so you could graph it if you wanted to. But if you take a look at these, if we just quickly sketch the graph like this, 2, 3 is going to be up here, 2, 7 is going to be higher, 2, negative 8 is going to be down here. So this is a line that looks like this. Okay, it's an x equals because the x isn't changing, and it's x equals 2. You just grab the number that you see every time. And it's because no matter where I go on this line, the y value changes. I go up here, it's 7. I go down here, it's negative 8. But it's always 2, 3, and 2, 7. Okay, the x value is always 2, so it's just x equals 2. So this one, the y value doesn't change, so it's y equals 12. Just a quick sketch. You don't have to do the sketch, but to help you visualize it here, we got 8, 12, and then negative 2, 12, and then 6, 12. It's going to look like this. All right, so that's a horizontal line, and no matter where you go on that line, the y value is 12. All right, and then look at this one. It gets a little confusing at first when you look at the variables, but notice the x changes. It's a A, it's a C, it's a D, but the y value is always B. So this is a y equals, and then just put the value. Just like when we had 12, 12, 12, we put y equals 12. We've got B, 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 so y equals B. All right, and now we're going to actually quickly sketch the graph for each one, kind of like we just did, except now we're just given the equation. So if x equals negative 3, you go to the x-axis, negative 3. It's going to look like this. X equals 5. You go to the x-axis, go to 5. The line that goes through it. Y equals 4. Go to the y-axis, up to 4. Y equals negative 2. Y-axis, go to negative 2. We're just sketching it, so that is good enough, just to get a general idea of what this looks like. Okay, and then 4.3, using tables and graphs to solve. So it says, suppose you're clinging to the bow or the bow of a sinking ship. You are starting off 8 meters above the water. There's sharks circling below you. So every minute the ship sinks a little bit, an additional 1.3 meters. So we're going to figure out basically when are we going to hit the water. person who wrote this exam review was having a little fun with it. Complete the table to find how long it will be until you are fish food, which would be when do we hit 0? 0 represents hitting the water. So we're starting off 8 meters above the water. And then every minute we're going down 1.3. So you're going to subtract 1.3 from this. Now we're at 6.7. Subtract another 1.3, that's 5.4. And then 4.1. And then 2.8. Again, subtracting 1.3 every single time. 1.5, 0.2, almost in the water. Then we would get some negative numbers here. If we were still sinking at the same rate, we're now sinking underwater. And so we're going to complete the table and answer the question, when do we become fish food? So here we're above water, here we're below water. So it's somewhere in between here. So to answer the question in words, you would say between 6 and 7 minutes. Now we could plug an equation and actually put 0 in and find out like the exact 6 point something minutes and calculate that and actually convert it maybe into 6 minutes and the exact amount of seconds. But based on this table that we've got here, we know it's between 6 and 7, and that's a perfectly acceptable answer. Okay, so for these, now we're going to solve and check. We've got a little bit bigger equations to look at. We're going to probably need to do these on a separate sheet of paper, but I'd like you to squeeze these in. That way you have everything here. If you want to do them on a separate sheet, then you're going to want to staple that to this. So actually, yes, let's go ahead and say that's what we're going to do. We're going to use a separate sheet and we will staple it just because these require so much work that it's going to be difficult to fit it all on there. If you can fit it, that's fine. So this is 4.4. Okay. And I'm not going to do the checks on here, but you have an answer key that's provided for you that shows the check. So if your check doesn't work out, go check the answer key and you can see that. So walking through these steps here, when you have an x on both sides of the equation, that's what was new here in chapter 4. We want to eliminate from each side. All right, and then so we're going to get 6x minus 5 equals 19. Add 5 to both sides. 6x equals 24. Divide by 6. And x equals 4. And now I'm not going to write it all out for the sake of time on this video, but you rewrite the original and you've got an x on both sides. So both sides now are going to get that. Now we haven't seen that based on what we just went over in chapter 3. One side of our check was always just a number, and then everything we did was on the other side. When we have these equations with x on both sides, now we have to work both sides of the check. So you plug in 4, you do 16 times 4. You plug in 4, you do 10 times 4. But you still keep everything separate on both sides of your check. You solve this all the way out, get a number, solve it all the way out, get a number, and you make sure that they're equal. You don't start trying to move things back and forth. Just a reminder, the only time we add or subtract from both sides and do stuff like that is when we have an x and we're trying to isolate it. Once we plug in the 4 here, or whatever number we're plugging in, there are no more x's. You just solve this side, you solve this side, and make sure they're equal. Okay. So the next one, 7 minus x plus 5 equals 4 times x plus 11. So variables on both sides with some distributing. Let's do the right side first, nice and easy. 4x plus 44, multiplying both by 4. Here now, first of all, the 7 is not being multiplied. It says 7 minus this. So don't multiply by 7. We do need to distribute the negative though, so it's like a negative 1. Negative 1 times x is negative x. Negative 1 times 5 is negative 5. And that's where most people make the mistake. They either multiply by 7, which is completely wrong, or they bring down the negative x and then they just bring down a plus 5 instead of multiplying it and getting a negative 5. Now, the right side here is fully simplified. I can't do anything with it, right? I can't combine those two. They're not like terms. But on this side, I do have some simplifying to do. These don't have an x, they can go together. So I'm going to leave my negative x alone. And then I'm going to put those two together. That's going to be a positive 2. All right. Once you have both sides simplified, this now is where you want to get your x's on the same side. The best practice for this is to always eliminate the smaller of the two. That keeps things positive. So this is a negative 1x and a positive 4x. If you get rid of the negative 1, which is smaller than 4, it will keep things in the positives. So we have to add x to cancel it, negative and positive to cancel. So we're adding x on this side. So 2 equals 4 and 1 is 5x. Then it's pretty standard, minus 44. So we're going to get negative 42 equals 5x. It's going to give us a decimal. That's okay. And this comes out to negative 8.4. Okay, the last one. I'm actually not going to run through this one. You can see it on your answer key if you get stuck. It's the same idea. It's just with decimals. It's actually just like the first one. You can see it's a minus and a plus. You would go through the same exact steps. You just have to deal with the decimal. I don't want those decimals to scare you. But again, for the sake of time on this video, I'm not going to run through that one. It looks just like this, and you can see the steps on the key. Okay, so now let's work on solving and checking these inequalities. Again, I would suggest staying on a separate sheet of paper for this. So this is 4.5. Same exact idea. So we're going to run through this fast. If at some point we divide by a negative, which we shouldn't if we're doing things with best practices, but if you did divide by a negative, you would need to flip stuff. So both sides are simplified. I can't combine anything on either side because one has an x, one doesn't. And so I've got an x on both sides. One of them needs to go away. Smaller of the two is the 2. So I'm going to minus the 2x. Keep this going. So it's 4x minus 10 less than 3. Pretty standard now. Add 10. 4x is less than 13. Divide by 4, no flip. Now, that's not going to divide nicely, so you could leave it as a fraction like this, or you could turn it to a decimal, which is probably easier to work with if you're going to go through your check. 2 checks again. So your first check, you're going to put equals. You're going to plug your answer in. Show you what it looks like. You put equals, and then you plug your 3.25 answer in. Simplify both sides. Make sure you get the same thing. Check number 2. Make sure you write this out on your paper so you've got it. You're going to rewrite the original with the less than sign, and then you've got to pick something that's in your solution set. Now, we didn't graph it, but if we did, less than 3.25 would include 0. 0 is less than 3.25. So you can plug 0 in, which makes your life very easy. And then you end up with negative 10 is less than 3. That's true. So we know that this is going the right direction. If this came out to a false statement, you know that you forgot to flip it or you flipped it when you didn't need to. Okay, so this would have to face the other direction. All right. These would be the same idea. Again, for the sake of time on the video, you can go through those on your own. Here's some special cases. So we're going to take a look at 4.6 here. Situations that always or never happen. This is when you're going to get those no solutions, and this is when you're going to get those all real numbers. Okay, so let's go ahead and see what happens here. When I go to solve this, here's my dividing line. I got to simplify both sides, so I'm going to get 3x plus 3. And then over here, 17x plus 13, I have to distribute a negative 2. So I get negative 14x minus 10. All of that is less than. You got to simplify this whole side. This one's done. So we've got a 17x minus 14x. That's a 3x. Put those together. 13 minus 10 is positive 3. All right, and When you see this, at first you might think it's all real numbers. If it was an equal sign, it would be because you have the same thing on both sides, but it's a less than. And it's saying 3x plus 3 is less than 3x plus 3. Both sides are going to be equal, so this can't possibly be less than. So when you get something that is untrue, that is going to be a no solution. You could go a step further and minus 3x from both sides. If you did that, you'd end up with 3 is less than 3, which is not a true statement again, and that's why it's no solution. So as we look at the other one, and we distribute, we're going to get 2x minus 2. We still have that plus 1. So don't try and distribute anything with the 1. It's not inside parentheses. It's just 2x minus 2. That's going to combine over here. So I have 2x minus 1 is going to stay. This and this combine to make a negative 1. So 2x minus 1. You could stop there. If you want to get it all the way down to regular numbers, you're trying to get x on one side. They completely eliminate because it was minus 2x on both sides. You get negative 1 equals negative 1. That is a true statement. And this is an example of all real numbers. So if you get something that is not true, it's no solution. True, all real numbers. Okay, and then 4.7. Solving some equations where you've got multiple variables and your final answer is not just going to be a number. You're going to have some stuff left over. And so we're just isolating whatever letter it's asking for here. So for this one, I want to isolate y because I'm solving for y. So I want x, I want the numbers, I want everything on the other side of the equation. So the first thing you should do is move this extra term. Whatever's attached to the variable that you're trying to save as your last part, that's going to be the last thing you get rid of. So the last thing we're going to do is divide by negative 8. But right now we're moving this 4x to the other side. So it gets out of here. So now I have negative 8y. Don't try and combine these. One has an x, one doesn't. They stay separate. I always like to put my x first. So negative 4x, that's a negative 40, so I'm going to do minus 40. All right, not a lot of room here, but I'm going to be dividing by negative 8. And that's going to get me to my final answer because now y is going to be by itself. So negative 4 divided by negative 8, two negatives, make a positive. 4 over 8, that's going to be 0.5. So you can write that as 0.5x, or you could write it as 1/2 x is fine. And then a negative divided by negative is a positive. And I'm just looking at the answer key. This was a mistake, so as you're looking, when they made this answer key, you've got the negative right, and it randomly became a positive. That's no good. So that is a mistake on the answer key. Let's fix it here. Two negatives are going to make a positive, so it's plus 5. So the answer key says plus negative 5. That's incorrect. It's plus positive 5. All right, all letters. We're solving for C. You want to get C by itself. These are connected, and that means multiplication. So to get rid of multiplication, we are dividing. Okay, so this cancels out, and you're done. C is by itself. I'm going to flip it and put C on the left side, but C equals A over B. Nice and easy. This one we want to solve for n. So n's got to be by itself. You save the attachment for last. So I'm going to add 360 to both sides. This goes away. So I have s plus 360. I cannot put those together. 180n. Now I'm going to divide by 180. S over 180, can't do anything with it. I now have n by itself. So n is going to equal all of this. You're going to have s over 180. And then this 360 divided by 180 is 2, so it's just going to say plus 2. All right, 4.8 is not on the original answer key, so we're definitely going to want to work through this one here. So compound inequalities, ands and ors. All right, so for this one, when we did this, we talked about how you can work all of this at once, and if you remember how to do that and you're confident in that, feel free. But we are going to go ahead and split this up into two separate problems. So it's negative 8 is less than 5m plus 4. And then you rewrite it over here again with the 5m plus 4. And you relate it to the 19. Just solve them separately. It's going to make your life so much easier. So we're going to get m by itself. We're going to minus 4. Negative 12. Divide by 5. We divided by a positive, so we are not flipping anything. Negative 12 divided by 5 is negative 2.4. All right, that's one of our answers. There's always two answers here, and we're going to look at it on the graph as well. Notice it didn't say check here. We're just graphing, so that saves us some time. All right, and then to solve this one, we're going to minus 4. And that's going to be less than 15. We're going to divide by 5, so m is less than 3. So less than 3, greater than negative 2.4. Here's 0. Here's negative 2.4. Both of these are going to be open circles. They don't have the equal sign on them. Positive 3 is going to be up here somewhere. And this says less than, so we're going this way. This one says m is greater than, so we're going this way. Okay, and so this is one of those problems where everything is shaded between, because we're looking for the answers that fit both of these situations. To make this equation true, or this inequality true, it has to fit both of these scenarios. So it's numbers that are greater than negative 2.4 and are also less than 3, and that would be everything in between. Okay, now this one is an or statement. It can be either one. So it can be true for this or true for this. It doesn't have to be true for both. That's what we're talking about when we have the or. All right, so this one, it's already split up. We're going to solve it as two separate. Okay, real quick solve. Minus 9. So 2x is greater than 8. No flipping. X is greater than 4. This one we got to be careful. We've got the negative attached to the 5. So first of all, the 8 is positive. To get rid of it, I have to minus. Don't get tricked. The minus stays with the 5. Positive 8. So I have to minus. The negative stays with the 5. We're going to end up dividing by that, and we're going to have to flip. All right, this is 5. Dividing by negative 5. X. And now I was going real fast there, but I caught myself. Divided by a negative, I got to flip this the other way now. So now it says greater than. And this is negative 1. And now when I put this on the graph, here's 0. Here's negative 1. Here's 4. Let's take a look and see what happens. First of all, these are going to be open circles to start with. This says greater than 4. We're going this way. A lot of times these ors go in opposite directions. In this case, though, because we flipped, this is also going this direction. And since it's an or, okay, it doesn't have to be true for both. If it was an and, then we're just looking at the overlap. So 4 would go up this way, negative 1 would go up this way, and so the overlap would be up here. But since this is an or, everything in this solution set counts, and everything in this solution set counts. But if we just take everything from this solution set right here, it's going to overlap and also collect everything from here. So since it's an or statement, I'm going up this way. It's going to go right through the 4. They would have overlap up here. But we have to include everything that's greater than negative 1, and we're also going to include everything that's greater than 4, but we've actually already done that. If we could just use this as our answer because it covers everything greater than 4. Everything that's greater than negative 1 is also greater than negative 4. All right, and then 4.9 is absolute value. So for these, we have to consider the fact that, like here, this answer could have been 17, but it could have been negative 17 because absolute value makes it positive. So 4.9. All right, so we have 5x plus 7 equals 17. What we're going to do is we're going to split this into two pieces. It could have been positive 17, but it also could have been negative 17. So we solve this one out. Divide by 5. So x could equal 2, or whatever we get over here. So 5x equals negative 24. Divide by 5. X equals negative 4.8. Okay, two solutions here with absolute value. Now here, if it equals 0, okay, it's only going to have one solution. I'll just do this one right on the paper because there's room there. Because even though this makes things positive, there's only one way to get 0. So I can actually just drop those off and solve this like this. Minus 13 because it's positive. We're going to get negative 13 over here. Divide by negative 2. We can get a positive answer here of 6.5. All right, now we can also look at these in terms of inequalities. So I'm going to come back over here on a separate sheet, and we'll work on this one together. So the first way to solve it is just like it looks. Okay, now we need this to be less than 10. So if you think about your negatives for a second, if it's negative and we turn it positive, it has to be less than 10. So it could be like negative 4 or negative 8, because then when it becomes positive, it's positive 4 and positive 8, which are less than 10. So if we get past negative 10, like negative 11, negative 50, and then make it positive, they're no longer less than 10. So if you think about your number line, right here's 0. Once we get past negative 10, and those negatives have the absolute value applied to them, they become more than this 10. So we need everything over here. So we need everything greater than negative 10. It's going to look like this, greater than negative 10. So the trick is you rewrite this just like we did, with the equals. You do it two ways. You're going to do it once with the positive, once with the negative. That's true here as well. But because we have this inequality, we actually have to flip the sign when we're doing the negative one. And a lot of people forget that. They know they got to do positive and a negative, but they rewrite it exactly the same way both times. When it's a negative, you have to flip it, and I explain to you why up here. Even if you don't understand why, you can just memorize, okay, I do it once the way I see it, and then when I do the negative, I flip it, and you'll get it right every single time. So minus 2, 4x is less than 8, divide by 4. X is less than 2. And over here, we're going to minus 2. 4x is greater than negative 12. Divide by 4. X is greater than negative 3. So we have 0. We have 2. And we have negative 3. All open circles here. They do not have equal signs. Less than 2 is going this way. Greater than negative 3 is going this way. So this is a situation where both of those are going to be in the middle. One more thing I want to talk about that was not on here. I'm just going to make up a random problem here. If we have 5x plus 2, this isn't the important part. Anything inside absolute value and it equals a negative number, right? There is no solution. Okay, that's important. If we're taking the absolute value, it's going to produce a positive answer. So if you ever see something equal to a negative, you don't even have to do the work. It's automatically no solution because it is not possible. And just looking over the key here for you. When we were up here and you're looking for that stuff, we didn't do all of those problems and all those checks, but you will find them on the key. Okay, they're pretty intensive, but you can follow along on those.